We can perform long division of polynomials just the same way that we do long division with regular numbers. So, for example, to take a ride in the Wayback Machine, let's say we were dividing 825 by 7. And so we wanted to do this using our long division algorithm. So the whole process would be to say, all right, how many times does 7 go into the first number that I see there, 8? We know that it goes in once. So then I put a 1 up top. Then I multiply. 1 times 7 gives me 7. I write that down here. And then we subtract. 8 minus 7, we get 1. And then at this point we would bring down the next number. So I bring down the 2. And then I go through the exact same process again. I say 7 goes into 12 how many times? It goes in once. And then I multiply. 1 times 7 is 7. I subtract. I get 5. And then I bring down one last time, so I bring down the 5 from up top. And so then I divide one more time, 7 goes into 55 7 times, we multiply to make 49, we subtract, get 6, and now we could either extend this by putting a 0.0 and then extending, or what we could do is we could take this remainder and put it over the divisor 7 to get our answer. So this process, this algorithm, is going to be the exact same one that we use when we apply it to the division of polynomials. So in my long division box here, my divisor, the x minus 1, goes on the outside here, and then I put the dividend on the inside. So I've got 2x squared minus 3x, and then plus 1. Now there are some differences in our approach and some of the way we describe the language of what we're going to do, but in principle the algorithm is the same. Our first step is to say, what do I have to multiply x by? And I'm just going to ignore the minus 1, it's just going to be along for the ride. But what do I have to multiply x by to make 2x squared? So hopefully we can see that's going to be 2x. X times 2x would equal 2x squared. Now just to line up my like terms, it's a good habit since we're going to have to do that a lot here, I'm going to put 2x above the minus 3x since they both have the same exponent of x. So even though I divided into 2x squared, I'm going to put the 2x over there. It doesn't really matter in the end, but it's just a good habit. So once we've done this division step, now we're ready for the multiplication step. So I'm going to take this 2x and I'm going to multiply it times the x minus 1. And this is what I mean by the minus 1 being along for the ride. Even though it didn't factor into my division step, I'm going to multiply it by the 2x just like I'm going to multiply the x by the 2x. So it's basically a little distributive property. So 2x times x is 2x squared, and that will always be the same. That will always be a match. And then the second part, 2x times negative 1 is negative 2x. So now I've done the multiplication step, so now I'm ready to subtract. So I'm going to subtract what I see in front of me. Now again, by coming up with the number that we did up here the way we did, we were always going to see these first pieces subtract. They're always going to be identical. Now I also have to subtract negative 3x minus negative 2x. And that is something that we have to pay close attention to. It is negative 3x minus a negative 2x. We're subtracting a negative, which means we're really going to end up adding. And so that means we do negative 3x plus 2x, which gives us negative x. So it's important that we understand that we're subtracting a negative, and so that's why we do our change to make it negative 3x plus 2x. And so once we've gotten to this point, we've finished our subtraction. The next step in the algorithm is the bring down. So I'm going to bring down this plus 1 right here, and then I'm going to go through one more round of division. So I'm going to say, all right, how many times does x go into negative x? Or the better way to frame the question is, x times what equals negative x? So hopefully we can figure out that that's negative 1. X times negative 1 would equal negative x. And so now I'm ready for that next multiplication step. So I'm going to distribute negative 1 to the whole divisor, to the x minus 1. So negative x times x is negative x. Negative 1 times negative 1 is positive 1. And so we finished our multiplication step. So now we're ready to subtract. And hopefully we see we're subtracting identical items. So negative x minus negative x becomes negative x plus x, which means those are going to cancel out. And then likewise, we've got 1 minus a positive 1, so 1 minus 1 also cancels out. And so then, in this case, our remainder is 0. So that means our answer for this division question is 2x minus 1. So we're just applying the exact same division algorithm as we did over here with regular numbers. Divide, multiply, subtract, bring down, and then repeat. Just like we saw with our regular numbers example, we divided 825 by 7 and got 117 with a remainder of 6. We can get remainders when it comes to dividing polynomials as well. And we handle it much the same way at the finish. But for this one here, I'm going to put my divisor out here, just like we did last time, so x plus 6. And then I've got x squared minus 5x minus 8 inside the box. So I'm ready to now go through my algorithm. So x times what equals x squared. So hopefully we know that's x. So I'm going to, again, line up my like terms just out of habit. So now I'm ready for the multiplication step. So I'm going to distribute. X times x is x squared. X times 6 is positive 6x. After the multiplication step, I'm going to subtract. So once again, we see that these first pieces are identical, so those always subtract away. Now we have to be careful for the second part. It's negative 5x minus this positive 6x. So negative 5 minus 6, it's going to give us negative 11x. We're ready to bring down the negative 8, and then we have one more round of the division. So x times what equals negative 11x. So hopefully we see that as being negative 11. And so then we multiply using a little distributive property. Negative 11 times x is indeed negative 11x. Those should always match up. And then I've got negative 11 times 6, which is negative 66. And so now I'm going to subtract one more time. We see that we're subtracting negative 11x minus negative 11x, or negative 11x plus 11x, so that cancels out. And then I've got that same idea where I'm subtracting a negative here, so negative 8 minus negative 66 becomes negative 8 plus 66, and so I'm going to get a remainder of 58. Now, I no longer have anything to bring down. There's no x in this number, so I don't have any more division to do. This is my remainder, and so just like we do with regular numbers, I'm going to put that remainder over the divisor. So my answer is going to be x minus 11 plus 58 over x plus 6. And so this is the answer to our division in this case. In our last example of long division, we see that our divisor here, x plus 2, is going to go on the outside. But then for the inside, I start off with 2x cubed. Then I have minus 6x squared. But then I'm missing an x term in my polynomial. So I need to have a placeholder. Otherwise, my like terms as I go through my division aren't going to line up. So the placeholder when something is missing is 0. So I'm going to have a 0x here and then plus 9. So the bottom line is, in my expression that's going to go inside the box, the dividend, I need to go in sequential order on the exponents of x. So if it starts with x to the third here, I need an x squared term, I need an x term, I need an integer term. If any of those are missing, I need to have a 0 hold the place. But other than that, this problem is going to proceed the same way the other two did. So I start with my division step. So x times what equals 2x cubed. So hopefully we see that is going to be 2x squared. So now I'm going to do that multiplication. So it's a little distributive property. 2x squared times x is indeed 2x cubed. We've got the match that we should have gotten. And now 2x squared times 2 gives us 4x squared. Ready for our subtraction step. So we subtract. These two are identical, so they subtract away. And now I've got negative 6 minus 4. So negative 6x squared minus 4x squared is going to give us negative 10x squared. And here's where I needed to have that placeholder, because now I'm going to bring down the 0x. to help line up all my like terms as I proceed. So now I'm on another division step. So it's x times what equals this negative 10x squared. So hopefully we see that is negative 10x. So I'm on another distributive property multiplication step. Negative 10x times x is negative 10x squared. We got the match that we wanted. If we didn't, then I'd know that the negative 10x that I put up top is not correct, but we did. And so I've got to multiply that negative 10x times 2 as well, so we get negative 20x. And so you can see why we needed that 0x, because we need our like terms to line up so that we can perform the subtraction step. So negative 10x squared minus negative 10x squared, subtracting identical things, those disappear. So now we have 0x minus negative 20x, so that's going to become 0x plus 20x. So we're going to get just regular old 20x down here. And now we've got one more bring down. I'm going to bring down the 9 and do one more round of the division. So x times what equals 20x? Well, that's going to be 20. So I'm going to have a plus 20 up here. And then one more round of multiplication. 20 times x is 20x. 20 times 2 is 40. Subtract one last time. 20x minus 20x subtracts away. 9 minus 40 is going to give us negative 31. And so now for my remainder, I can either put it as negative 31 over our divisor, x plus 2, and have that be an addition symbol there. Or the other way that I could write this is, if we erase that, if that 31 is negative, if the remainder is negative, then we can say, well, let's just make it minus this remainder. That's the equivalent of doing plus the negative 31 over x plus 2. So either way you write it is just fine.